Good afternoon, everyone, or morning if you're on the West Coast. My name is Tom Mondor, and I'm one of the technical sales reps for Gusmer Enterprises. Today, we have a webinar discussing the real-time monitoring of dissolved oxygen in process using Hamilton's Visiferm and Visitrace sensor probes. And without further ado, let's move on. So, today's agenda, briefly, we'll discuss Gusmer and Hamilton, our company and what we do. Then we'll have Kelvin, who is the product manager for Hamilton. He will discuss and introduce the Visiferm MA and Visitrace MA sensors. Then we'll delve into the different sample points that can be found in a typical brewery and the critical control points that we'll often see, and how oxygen gets into our beer or our wort. Then we'll discuss the differences between inline and spot checking using a mobile sensor. And then we'll get into the technical aspects of the different sensor housings available, how to calibrate the sensors, and the ArcAir software. During the webinar, if you have any questions, I ask that you please type them into the Q&A box in Zoom. That way, Peter Stentfort, who is our digital marketing manager, will get a copy of that and be able to help us with the Q&A at the end of the session. All right, let's move on. So a little background about Gusmer. Gusmer is a family-owned company founded in 1918 and is in its current third generation of both management and ownership. Our mission statement since 1924 has been service with knowledge. We specialize in fermentation and filtration products and services for the food and beverage industries, but we also produce products for the biotech and pharmaceutical industries as well. Along with our numerous manufactured products, we also have a wide variety of vendors like Hamilton that we work with to provide all sorts of equipment and services to the beverage industry. Our manufacturing facilities are located in Fresno, California and Waupaca, Wisconsin. We also have 2 retail stores in Napa and Windsor and a shipping warehouse out of New Jersey. We have 15 direct technical sales representatives, of which I am one, 4 product managers and 3 application specialists, and then 16 research and development scientists located both in Wisconsin and California. If you have any questions after the webinar today about the products that we're going to be discussing or anything else, I ask that you go to gusmerenterprises.com, click on Find a Rep at the top of the screen, and then enter in your city and state. Hit the go button, and you should be connected with your technical sales rep for your region and industry. All right, Hamilton. Hamilton has been manufacturing precision measurement devices for over 60 years. We've been working with Hamilton since 2014 and have had an extremely good relationship with them since then. Gusmer is Hamilton's sole distributor for the beverage industry, and that includes wine, as well as beer and spirits and juice. Here we can see just a brief overview of all the different applications you can find for inline process monitoring. So on this sheet here, you can see both dissolved oxygen, but also pH and ORP. And you can see there's a number of different sites that you can be measuring to fine tune your process and improve the quality of your product through these process controls. A lot of people don't even think about adding them in certain applications, and we'll discuss some of them, but there is a wide variety of areas that these can be implemented pretty easily to improve your processes. So why do we measure dissolved oxygen? Well, the first reason is yeast health. So dissolved oxygen is required in wort. And different yeast strains require a different amount of oxygen. And the oxygen helps the yeast cells synthesize sterols and unsaturated fatty acids. This will help grow yeast, both in your propagator, but also during fermentation of your beer. We also want to look at flavor stability and shelf life. So oxygen can induce a number of different reactions in finished beer, including creation of aldehydes like trans-2-nonenal, which can give you those cardboard wet paper flavors, as well as caddy flavors or tomato leaf or black currant flavors. And with severely oxidized products, you can get even sherry-like flavors. And another excuse me, thing to consider too is your shelf life. So Large amounts of dissolved oxygen in finished beer can change the color of your beer. It can also help form colloidal hazes when oxygen reacts with heavy metals like copper or iron. So by controlling dissolved oxygen upfront, you get healthy fermentations, the flavors that you're looking for. And then by controlling it on the back end in your finished beer, you are going to be preserving those flavors that you're looking for. So without further ado, I'd like to introduce Calvin. Calvin is the product manager for the beverage industry at Gusmer Enterprises. Calvin's educational background focused on biochemistry and biotechnology, and he has been with Gusmer for 18 years in R&D and specialist roles previous to his product manager duties. Calvin is currently based out of our Fresno, California location. Calvin, please take it away.
Hello, everyone. So I just wanted to talk about Hamilton's newest product offering for the beverage industry, and those are the for dissolved oxygen inline sensors, and those are the Visiferm MA and the Visitrace MA inline sensors. These were released within the last year, and what's great about these sensors is they have not just integrated transmitters as Hamilton's previous sensors have had, but also they have built-in Bluetooth communication ability. So you don't have to purchase any kind of Bluetooth adapters. They already have Bluetooth built into the sensor, which is excellent if you want to check the amount of dissolved oxygen in your tank or line from your phone, for example. So it's a great feature. Hamilton simplified the wiring in these new offerings. It's a two wire loop now, so that you can both power and connect to your 4 to 20 with just 2 wires. It's also HART compatible. The Visiferm MA is the wide range sensor for DO measurement. It can go down to 10 parts per billion and all the way up to 25 parts per million. So it's a wide range sensor. You would typically use this sensor in your wort aeration or yeast propagation areas. There's also 2 different cap choices for the Visiferm MA. There's the H3 cap and the H4 cap pictured there on the right. The H4 cap is a more robust sensor cap that's available that gives you increased resistance against chemicals and also against the formation of bubbles or little pockets of CO2 on the sensor itself, the sensor cap. So the Visitrace MA sensor is the low-end sensor from Hamilton. It can go down to 0 parts per billion up to 2 parts per million. So this is the sensor that you would use in your finished product or your bright tank. The new L1 cap that was just released is stable against active chlorine and chlorine dioxide, which is a great option if you use that in your brewery. And both sensors can be CIP'd. Another sort of advantage that these new Visiferm and Visitrace MA sensors have over Hamilton's previous offering is that the sensor cap life has increased as well. So previously, you would have to change a sensor cap maybe every 3 months. Now you only really would have to change a sensor cap every 12 to 18 months with this new improvement in the sensors. So it's a great step forward for Hamilton, and Gusmer is proud to offer these 2 sensors. I just wanted to discuss the optical technology that these sensors use so that you understand how it works a little bit. So previously, previously dissolved oxygen was measured by polarographic technology, or Clark electrodes, as they're previously referred to as well, which were great, but they required a lot of maintenance. You had to basically do kind of a mini rebuild on your sensors over time. With this new optical technology, all you're really doing is changing a sensor cap. And I talked about that before, that Hamilton has had optical sensors for a number of years, and now they've even improved their own caps so that they last longer. But anyway, the way the optical technology works is there is a film on what's on the sensor cap, and there's a picture of it there at the right. But the film on that sensor cap is called luminous 4. It's an oxygen sensitive chemical, and what happens is there's a blue LED inside the sensor. That LED will shine on that luminous 4. The chemical will be go into an active state, and then it will release red light as it comes back down to the ground state. And that amount of red light is picked up by the sensor. In the presence of oxygen, when that red light is released, some of that energy will interact with oxygen. And what that oxygen does is it reduces the amount of red light emitted by the luminous 4. And so the sensor can pick up that reduced amount of red light and then determine how much oxygen is in the environment. So that's kind of how the optical technology works. Again, with the Visiferm MA and the Visitrace MA, you only have to replace the sensor cap every 12 to 18 months. And then you would probably only have to calibrate these sensors every 3 or so months. So it's great technology. With that, thank you. I'll pass the ball back to Tom and let him continue with the applications.
Perfect. All right, so now we're going to be discussing the different sample points of what we're going to be wanting to place these sensors in your facility. So the first one we're going to be discussing is the Visiferm MA, which is that high-end dissolved oxygen. This is going to be for monitoring your wort aeration, but also for yeast propagation. So as we discussed earlier, sufficient oxygen is key to healthy fermentation, and every yeast product that you use, different strains, different vendors will have different requirements. So to get a really good understanding of this, it's going to be a little bit of experience on your part, but also working with your yeast vendors too, to get a good understanding of what the requirements will be. So the Visiferm can be used with all types of systems, both manual and automatic. And using these allows you to have real-time numbers during your wort aeration. So you can then monitor and adjust oxygen levels during your pump back into your fermenters and be able to adjust. And I know, depending on how many production folks we have on the call today, we've all run out of oxygen tanks before, and sometimes it's not always caught immediately. So by having inline monitoring, you can see exactly when that oxygen tank needs to get replaced by seeing the numbers dip. These sensors can be used with Bluetooth, as Kelvin explained, and we'll go into a little bit about the Bluetooth functionality a little bit later. But they can also be wired into your PLC or HMI systems for complete automation, or to work with your existing system for readouts. They can be CIP'd in line, so no need to remove them and take them out to clean. They can remain in the pipe, and they are extremely easy to add in. So with some simple housings, which we'll look at later as well, they can just be added into your existing pipeline, or even in addition to your soft hose. And on the yeast propagation side, it's extremely important to monitor the dissolved oxygen to ensure that the yeast remain in a mostly aerobic state. This reduces the amount of alcohol they produce and increases the maximum amount of biomass that you're going to produce, which is really the key thing for yeast propagation is making sure that we're growing lots of yeast. So by oxygenating and making sure that the wort is aerated sufficiently during propagation, you're going to get the most out of your propagation. And just like on the wort side, you can utilize these with an existing PLC and HMI to inject air and oxygen only when needed or at different intervals. All right, so now we're going to move on to the Visitrace, which is the low end side. So after fermentation, oxygen is detrimental to beer, as we discussed, and causes stability and staling issues. And this is important for a lot of reasons. Especially if you're going to be moving into new markets, this beer on the shelf, we don't like it to be sold 2 weeks after it gets delivered to the stores or to the distributor, but it's not always the case. So we need to make sure that the beer is stable and remains the product that you want representing your brewery for as long as possible. So that's why this is so important. So it's important to measure both dissolved oxygen pre and post filtration or separation to pick up any issues that you might encounter during those operations. I actually Just was speaking with a customer of mine last week who had an issue with their separator, and they were having an ingress of oxygen somewhere in their system, and they could not figure out where. Luckily, they did catch it and were able to figure it out, but something like this can kind of crop up out of the blue, and if you're not watching, if you're not monitoring, it's going to sneak up on you. So some common sources of where oxygen is going to get picked up in the system would be bad clamps and gaskets, pump seals that are damaged, insufficiently purged pipework, or other equipment, your CO2 supply, filter seals on your plate and frame, or even on your cartridge or lenticulars, the oxygen in your diatomaceous earth feed tank for your DE filters, human error, which does happen from time to time, as well as process and ingredient water that you might be adding into your system. So these problems, as I mentioned, they can occur at any time during a run. So that's why monitoring in real time is key, because as soon as something happens, you can react quickly and ensure that your product remains, what you want it to be. So monitoring and dissolved oxygen between bright tank and patch line is also crucial. You can actually place these sensors in the bright tanks in the headspace too, to monitor dissolved oxygen in the headspace. Other sources of oxygen on the packaging side could be tank purging with the bright tank. So when you're blowing up the tanks with CO2, you want to make sure that you have all the oxygen removed from the tank before filling with beer. Flash pasteurizers can have leaks, especially in the heat exchangers. Oxygen can get in that way, as well as tank carbonation. You want to make sure that the CO2 that you're receiving and using in the facility is exactly what you're paying for. There have been instances where you would get a lower grade of CO2, and then you wouldn't be able to necessarily check that unless you are monitoring that. So you don't want to add in a bunch of oxygen while you're trying to carbonate your beer and tank. And also another thing to keep in mind too is that when there are oxygen problems or downtime on the packaging side, it's extremely costly. Packaging lines typically have the most people working, a lot of moving parts, and you have a lot of other expenses too, like packaging. So that if there is an issue and you don't catch it right away, are you going to recall the product? Are you going to have to dump it all? Are you going to have to destroy it? So making sure that you're watching these things and monitoring them in real time is extremely important. Some other sample points I just wanted to touch on real quick that are outside of the scope of packaging and wort fermentation would be your deared water plants. So if you have a current deared water plant or looking to purchase one, it's important to measure the dissolved oxygen to ensure that your deared water plant is working correctly. But also if you're using something like a buffer tank, to make sure that the water going out of that tank is also within spec. Blending equipment for high gravity brewing or possibly flavor dosing too would be an important place to put a dissolved oxygen meter. Bulk CO2, which I touched on briefly, just make sure that you're getting what you pay for. Transfer lines between buildings or into tankers, making sure that they're purged out sufficiently with CO2 or deared water, that there's no oxygen in those lines still. And some of them can be pretty sneaky. If they have any weird rises or curves, little bubbles can form, and you want to make sure that you push everything out so you don't have any oxygen just kind of sneak up on you. Another thing too is this might not be for all craft brewers, but CO2 recovery systems. You want to make sure that monitor those with dissolved oxygen as well to make sure that the purity of your CO2 remains stable. So we want to talk about a little bit about inline and spot checks. Mobile dissolved oxygen meters are fantastic. They're very versatile, like the Hamilton Beverly. The Beverly can check both high and low end DO, but there are some limitations to what it can do. And sometimes it makes a lot of sense to stop using that on a regular basis and move to more of an inline solution. So you get instant readings with inline solutions. You don't have to stop and check and wait for temperature equilibration. It's pretty quick to get a reading. You also have the labor aspect too. You don't have to have someone going around and checking different sites. You can literally use your phone or tablet or computer to just look at what the sensor is currently reading. There's no lost product. So we've all sat around and had to check dissolved oxygen out of a tank or CO2 out of a tank and waiting for everything to equilibrate and beer's just going down the drain during this process. There's none of that. It's inline. There's no product loss. Another aspect too is data tracking. So depending on your current SOPs, you might have a form you fill out, or every tank might have a sheet that you track stuff on. Using a PC and the ArcAir software, you can track the data and have it exportable too. So just a couple of typical DO values we're going to blaze through real quick. So most of these are pretty low, and that's what you want to see. The lower, the better. And someone told me just yesterday that every time that the beer or product moves is where you're going to want to check it. And you can kind of see that all those are kind of covered in this little document. So geared water and post-fermentation, both of those are less than 20 parts per billion. Those are ideal numbers. And like I said, the lower, the better. With wort, we're going to see anywhere between 10 and 20 parts per million. And that's going to be dependent on style and gravity of the wort, but also temperature and pressure. So your loggers might have a harder time getting that oxygen to dissolve because you're pumping back at a lower temperature. So something to keep in mind. And then for post-filtration, centrifugation, and transferring, 50 is kind of the top limit is what we like to see. And then the packaging line and bright tanks below 20. And then once again, looking at your bulk CO2, making sure that you're getting what you pay for there and that there's no oxygen in there. So a quick overview of the sensor housings here. We do have a couple different styles, the tri-clamp and the Visiferm or inline fixed place housings. A few samples there you see on the screen. So we do have 3 different types. We have the 90-degree or straight on type there on the bottom. We also have the 15-degree option available, which is on the far right there. And that does help protect the cap a little bit more, and you can see some extended life out of it using those. Then lastly, we also have the retractable housing, which might be something that's beneficial for some folks, being able to remove the sensor, especially in very busy packaging lines or filtration lines or brew houses that might be running 24/7. It's hard to find time to stop and calibrate all the time, especially if you have to take the pipe apart. So with retractable housing, you can remove the sensor and do any calibration work that you might need to do, and then put it back in line without having to have an actual stoppage of production. And with that, I'm going to reintroduce Kelvin again. So take it away.
Thanks, Tom. I just wanted to discuss calibration of these sensors, which is a critical piece to making sure the sensors are giving you accurate data. For the Visiferm wide range and sensors for the Visiferm MA, you'll need 2 different gases. One is a certified 99.999% nitrogen, and the other gas is 20.9% O2. The 20.9% O2 is actually, another word for that is certified air, but it's essentially air in a cylinder that's been certified at 20.9% oxygen. And why you need 2 different gas standards is what you're doing when you're calibrating these sensors is you're using a low point near 0 and a high point at the 20.9% mark. Why it's important to use a certified 20.9% oxygen is you're telling the sensor that this is how much oxygen is in the environment, and I want you to set yourself at this point. So if you were to use, say, maybe if you were to calibrate in air, for example, or if you were to calibrate using an air compressor, what can happen is, depending on your elevation or how much moisture is in the air, you can set the sensor at a bad spot, just because moisture will reduce the amount of O2 in the environment. So really dried certified air is the best way to go when you're setting the high point for the Visiferm MA. For the low point, we really recommend 99.999% N2, or it's called 5 nines. And that's just because that is that percentage provides an ideal amount of provides the ideal amount of low oxygen in your environment. So if you were to use 99.9% CO2, which is the common amount of the common grade for food grade CO2. The 3 nines really, you could have enough oxygen in there to throw off the low point for calibration. So the 5 nines ensures that the oxygen level in that nitrogen is so low that you'll have a good low point calibration. For the Visitrace MA, again, 99.999% nitrogen. And then at the high end, you'll have a 1% oxygen gas standard. The calibration of these sensors, typically you'll want to calibrate about every 3 months or so on these new Visitrace and Visiferm MA caps. It really varies depending on how much product flows through the process and how often your sensors are in use. But typically that's about correct. Previously, you'd have to calibrate once a month on the old style sensors. There's 2 different ways you can calibrate the sensors. Hamilton has what's called a calibration station, where you can connect your certified gases to this device, and then you can screw in your sensor at the top, and then valve open your gases appropriately, and use the ArcAir software to calibrate. The other way you can calibrate is there's what's called a calibration sleeve, which is again, Hamilton also offers that, but you can just connect the tubing on the sleeve to your gas, and then slip the sensor right into the sleeve. When you calibrate your sensors, it's very important that your sensors are clean and dry prior to calibration. Any kind of dirt or crud on your sensor cap can affect your calibration. So you want to make sure they're clean, they're dry. You also want to make sure your sensors are at the same temperature as your calibration gas. If your sensors are still cold and your calibration gas is at room temperature, that can affect your calibration. So you want to make sure that the temperatures of the 2 are in sync. And the software that you use to calibrate the sensors is called ArcAir, and we'll talk about that on the next slide, but it's a very convenient, easy way to calibrate your sensors, and it has the really good user interface. So about ArcAir, the software is available on PC Windows and also available on mobile devices, both Apple and Android. The software is free to download with the exception of the GMP compatible documents. So it's free to download on tablet, phone, and on PC. You can monitor up to 30 sensors simultaneously using the software. You can also set up experiments in the software that allow you to track data. And this is on PC, but you can track data and record data for up to 3 months on 3 different sensors. So say you wanted to start an experiment, call it tank 1, you had a DO sensor in there, and you had a pH sensor in there, and maybe you had a conductivity or ORP sensor in there. You could select 3 different sensors for that tank and monitor that tank for 3 months. And you can then take that data and export it into CSV. So it's a really great tool to track your data. On the data recording is on PC only, but you can still monitor and calibrate those sensors on your phone or tablet. Again, yeah, the software is used to calibrate the sensor. It's really user friendly and intuitive. Here's a slide here that kind of shows you what you might see on the software on your phone. So in the upper left-hand corner, it shows you what sensor you're using, what the current warning messages say, what the current value is right there, 9.91%. You can change the readout from percent to ppm to ppb. Right there, it shows you in the upper right-hand corner what the sensor name is. Your quality indicator, that's really important. So that tells you when to change your sensor cap. Below 50% is about really when you should consider changing that cap. You can get a little bit more life out of it. As you can see on the right, there's a table there where under 35, you really need to replace it. But we typically recommend under 50 because that's where you can see a little bit of performance shift there. You can see your maximum temperature. You can see, operating hours, CIP cycles, and all that kind of good stuff for each sensor too. And then at the bottom, you can look at, your current warning messages and when you should calibrate.
All
So
right.
we'll open it up to questions now. We'll bring in Tom, and we'll bring in Jeff Tosio, who is the OEM and beverage manager for Hamilton. Jeff has had a number of years of experience working with DO monitoring in brewing applications. If you have any questions, please type your questions into the Q&A box at the bottom, and we'll get those answered for you.
And with us again is Peter Stenford as well. So Peter, are there any questions that we can answer?
Looks like there's one question coming in right now. Why would you use a angled housing versus a straight housing?
I can take that question. The angled housing is good for increasing cap life. So also, if you have to have, Hamilton recommends that your housings be placed 6 feet away from any pipe bends or turns, 10 feet preferably. But if you have to have any sensors near a pipe bend, what you can have is sometimes you can have this turbulent flow or these eddies that flow into the pipe. There are these pockets of air. And what you can do with the angled housings is you can insert them in with the flow of product for A, better performance, B, an increased cap life because you're not hitting that sensor cap with those with the flow, and just the last thing that can happen, especially with carbonated products, is you can have bubbles that kind of build up on the sensor, little micro bubbles that kind of sit on the sensor cap there. And having the sensor installed with the flow of the product will kind of, reduce that phenomenon. And so you can have a better performance. So it kind of inhibits the little bubbles from forming on the cap. But good question.
The next question we have, what's the cost difference in a fixed housing versus retractable housing?
That's another good question. So fixed housings you're looking at, $700 or so. And retractable housings are, I want to say they're in the $2,000 range. So I would say nearly triple the cost. But where retractable housings shine is the fact that you can pull the sensor out if you have a tank full of product, or if you have a line full of product, and you can't, pull off a tri-clamp because you'll open the environment and spill product all over the floor. If you have to open the tank and there's product inside and you have to do a quick recalibration or a quick sensor cap change, you can do that. So that it does give you a lot of flexibility there.
Next question, are there any considerations for areas not to use these sensors, i.e. downstream of aeration lines, centrifuge, etc.?
Yeah, I think Kelvin kind of mentioned that. Ideally, you're going to want to have the sensor an appropriate distance downstream of aeration and carbonation, things like that. So we want to make sure that that flow is laminar as possible. There's no turbulent flow, but also we want to make sure that, especially at points of aeration, that oxygen is dissolved fully in solution before it hits the sensor. Jeff, do you have some things you want to comment to?
You just want to ensure there's good mixing so you don't have air pockets in there that you're not going to get a true reading for your dissolved oxygen reading. So typically, like for water aeration, you're going to put the sensor downstream of the injection point, a good distance to make sure that everything, mixes in before you drop it in the tank. So great question and very accurate.
The next question we have, can you calibrate these sensors inline, or do you need to take them out and perform calibration in the lab?
Do you guys want me to take that?
Sure, go ahead and take that, Jeff. I
So,
know. Go ahead.
sure. So in practice, it would be great to do everything at the line. But as Calvin mentioned, the main concern is that you don't try to calibrate a sensor that is wet or one that is at a different temperature than calibration gases, because you will get a bias, which is an offset on the actual sensor itself. And so what I've done in the past and works really well is if you have these installed in your facility, you may want to go through even kind of a rotation where you pull a sensor, bring it into the shop or the lab, let it dry out overnight, calibrate it in the morning, and then put it in, install it, and then maybe swap another one. So if you have, say, 4 sensors, maybe you have installed, maybe you have a 5th one, and you rotate through. That way you also always have a spare sensor you can hot swap if there's a problem and keep running. So I've worked through these in a number of cases where we've tried to do this, and you always end up with some type of a bias if you try to do it at the line.
And it looks like those are all the questions that we have for today.
Great. Well, if anyone does have other questions, as I mentioned before, you can reach out to your technical sales rep using the gusmerenterprises.com website. So coming up, we do have a couple more webinars that we're going to be talking Hamilton products. The next one's going to be on March 9th, talking about pH and conductivity. And then 2 weeks after that, March 23rd, we're going to be talking ORP in the fermenter. So those are going to be both very interesting talks. So I encourage you to sign up. And one more time, gusmerenterprises.com, find a rep, and click on go, and you should be connected to who you need to talk to. All right, I think that's it. Thank you, Calvin, Peter, and Jeff. I appreciate your time today. And thank you, everybody, for joining us. Have a good day.